Artificial intelligence. So this is a very big topic, and I'm going today to discuss artificial intelligence and its relationship to machines, and exactly to the machine condition monitoring, which is my topic and my research interest. I need to tell you about how you can use artificial intelligence for the machine condition monitoring or for the maintenance. Artificial intelligence can be used smartly and intelligently to be applied or utilized for machine condition monitoring. And why we want to do this, and why we want to understand how it works. First of all, we'd like to know about the objectives of this field of artificial intelligence for the machine condition monitoring. First of all, of course, we are looking for automatic fault detections. If you want to discuss about the machine condition monitoring, so machine condition monitoring, we want to do monitoring and we want to diagnose the different faults that could be happening for the machines. Machines like, for example, mostly would be rotating machines like the centrifugal pumps or the compressors or the gas turbines and others. And we want to know the objectives. So one of the main objectives, as I said before, will be the automatic fault detection. So instead of using the manual one or depending only on the human intervention for the faults and for the faults analysis that being acquired by the human beings, and then later on there might be some misinterruptions or misunderstanding of the vibration behaviors of the other or any other parameters, like for example the pressure and the temperature, and the judge will not be accurate. In this case, we would like to reduce the errors and put a very good system, automatic system, that could understand and could diagnose the faults smartly, intelligently. And we have also other objectives that we want to make accuracy or very high accuracy for the understanding and the behavior of the machines. And I can bring a very good example for this. If we just start to understand how we can apply or utilize artificial intelligence for the machines, and perhaps I can bring a very good example for this, which is a centrifugal pump. So centrifugal pumps are mostly complex machines which could or can have different type of faults, and faults could be also categorized with centrifugal pump into two main parts: hydraulic and mechanical faults. For the mechanical faults will be different also type of faults, like for example the misalignment, imbalance, mechanical loosenesses, and bearing fault, impeller fault, and so on. And for the hydraulic one also we have some other type of faults which is related to the variation of the pressure, and mostly the main one will be cavitation. Now the question is how I can use artificial intelligence as an automatic diagnostic system or as automatic fault detection system in order to classify the different type of faults. Of course, there will be different methods and tools or algorithms that could be utilized through the artificial intelligence. Since artificial intelligence is a smart or intelligent tool and is related to the science to the computer science, so we need to understand and we need to use it as analyzer to analyze the behaviors of the machine. And the best thing that I believe we can have it in order to understand the behavior of the machine, which will drive us to know about the condition or the overall condition of the machine, and later on of course to diagnose and to classify the different type of faults that could be having for this certain type of machine. For example, as I said, the centrifugal pump. So will be artificial intelligence. We need to understand it clearly, and we need to use some particular tool which is related to artificial intelligence. And one of these tools could be artificial neural network, and sometimes also known as the multi-layer perceptron neural network or feed-forward neural network. And this one could be applied along with a learning or training algorithm, which is well known as backpropagation. But with another videos and another topics, so we are going also to discuss about the other type of algorithms that could be used as trainers. For example, we have also genetic algorithm, but I'm not going to discuss this today, so my focus or my highlight will be only for the backpropagation. First, before going to this, let us discuss about the nature of the centrifugal pump. So the centrifugal pump, once we want, for example, let's say that we are going to have a visit, site visit to any industry, and we are targeting a particular or certain pump in this field or industry. So we want to check what exactly the faults could be happening for this, but we don't want to use the human beings understanding or interruption, and instead of the human being, so we need to use the machine learning or the computer, or as we know it as artificial intelligence. In this case, this artificial intelligence going to do a automatic classification for different type of faults. But at the beginning, we need to understand that we have to consider the artificial intelligence system, which could be represented, as I said, in artificial neural network or multi-layer perceptron feed-forward neural network, could be considered as a baby. So we need to train him, we need to teach him, and we need to allot some algorithm for the learning. So at the beginning, we have to identify the different faults, and we have to collect or identify the highest number of faults that could be happening for this machine. And once we collected the different faults, we can just consider different parameters, or we have to focus on one parameter, let's say the vibration. And from my point of view, I feel that vibration is the best, since vibration could give us very certain signature or particular signature for each type of fault. For example, if we want to check the misalignment will be with its own certain signature of vibration. And the same thing for the other type of faults, like for example the imbalance or mechanical loosenesses, even the hydraulic ones with each cavitation. But we have to be careful that we have to be with very good knowledge about the norms or the standards of the vibration. So we have to know how it looks like vibration of the vibration signature or the frequency signature of the misalignment, and we have to know according to the norms that about the other faults. And once such background or understanding well with us, and we are very good with this, so we have to introduce such faults, and we have to make our own categorized faults, and we have to introduce them to the neural network system. So at the beginning, we have to identify its faults, and we have to put some parameters, and we have to extract some features. So once, for example, we did acquire all the faults from the machine, let's say we acquire different mechanical faults and also hydraulic fault or other hydraulic faults. It might be cavitation and turbulence, let's say. So once we are going to collect them or acquire them, we are going to extract some features out of them, and that could be happened by using the pre-processing system. So pre-processing system could be done using different also other tools, like for example or algorithms, like for example the wavelet transform. From my point of view also, I believe that wavelet transform is a good one, since wavelet transform, if we compare it to FFT or the frequency domain, will provide us better pre-processing for the features that's related to vibration, and then it is able to distinguish or to work with both type of vibrations, the non-stationary and the stationary. compared to the frequency domain, which is only able to work only with the stationary, not the non-stationary. In this case, we have to think about the wavelet transfer, for example, but for you might be you have another type of preprocessor that you can use it. So the wavelet transfer, once we want to apply it, so we have to ask the wavelet transform to extract some features for us, and the features will be in different numbers, so our different values. Finally, we have to categorize each parameter and each features to its own single fold. Let's say we have 8 or 7 folds, and the 7 folds will be with each one will be with its own features, number of features. Let's say we have for each feature 100, for each fold we have 100 features. And we have, let's say, different other parameters. For example, we can use kurtosis, we can use RMS, we can use peak, we can use peak to peak, and other parameters. Now, the number of folds along with their own number of features will be considered now as input. And the inputs should be now forwarded to the neural network. And now if we just want to imagine how it looks like such system of artificial intelligence based on the multi-layer perceptron neural network. So it will be going to be divided into 3 layers or parts. The layer number 1, which will be known as the input, which will receive the external input, which are now known as the inputs, which are now known as the features, which are related also to the folds of the PEMs. And we have also the second layer, which is known as hidden layer. So the hidden layer is, I believe it should be known also as the brain layer, where the main calculation of the neural network will be there, and the mapping between the input and the output. So the third one, or the last layer, will be the output. So now we have to imagine that we have input, we have hidden, we have output, and we want to do some relationship or mapping between the input and the output. Who can do this? This will be done by the hidden one, or the middle layer, which is the hidden layer. And now we have to understand how many neurons or nodes should we have for each layer, or how even many layers. But mostly for the input will be 1 layer, but with different number of neurons. According to what? According to the number of folds we have. Let's say we have, for example, 7 folds, so we have to consider 7 neurons, or according to the number of the parameters. And for the hidden, it is little bit complicated and complex to identify or decide the number of neurons, but that could be also used or could be decided using such optimization tool, like for example the genetic algorithm for the automatic selection of the number of neurons or nodes. But manually we can do it. For example, we can do some different attempts. We can use, for example, 3 neurons and 4 layers, and for each layer, for example, we have to identify, for example, 30 neurons, 40 neurons, 50 neurons, and just we have to keep trying. But my advice always is to use optimization method or algorithm. Mostly genetic algorithm was found to be very good for this duty. So the calculation will be done there, and the calculation has to be done according to adjusting the weights. So there will be some weights, also will be bias, and that will be all together, summed all together, and then the neural network or the hidden layer has to take the role of calculating the weights. And the calculating of the weights has a desire to minimizing the mean square error. So there will be some desired mean square error that you already set it, and you have to reach that or you have to go below it. Mostly has to be very, very small, so below, so let's say 0.00 something. And once you are reaching this level of mean square error, or you did go to the lowest or the minimum mean square error, it means that you reach the desired level or training, and the training should be now stopped. So training once will be stopped, that means the system or the model of artificial intelligence is now well introduced to the faults, and now this system has full awareness about the future nature of the faults, and each fault is already categorized for this and well known to this system. Now the output has now the ability to classify. So in order to make the output do the classification, that will means you will have class for fault number 1 for example misalignment, class number 2 for imbalance, class number 3 for the mechanical loosenesses, and so on, or even cavitation. And that will be the phase number 2, which is the test. So you have to test now the machine with unseen set of features. The previous one will be seen, and because that you did introduce that for the system in order to understand them and in order to make them clear to it. But now you will not have to be seen to it. So you have to make them hidden, and you have to introduce them as just random features. So the system has now, with previous understanding and the pre-knowledge about such faults and behaviors, will have good ability to identify each type of fault. And that's the system. It works like this one. Now the question is then how I can use this system in future. For example, I have to test it with other type of machines. So for example, you did test it with the centrifugal pumps, and mostly centrifugal pumps is a main rotating machine, so you can also use it for any other rotating machines. And once you want to test it, for example, for other centrifugal pumps, mostly you already consider and train the system with specific common faults, mechanical and hydraulic. So this new centrifugal pump that you are going to approach and you want to test it, mostly will have, if there are already some faults, the signature or the vibration frequency signature of such faults which are available in this centrifugal pump. The new one mostly will be resembling or similar to the previous one that you already tested, and that will make you go directly to the test phase, where you have to ask the system or the artificial intelligence model to diagnose and do the classification for you. Surely we have different type of other faults, other artificial intelligence classifiers, but just today I give you a brief idea about this type of artificial intelligence classifier, which is multi-layer perceptron neural network. Hopefully you get some idea about this one, and seeing you next time, where we have to discuss about the other types, other algorithms, and also we have to discuss about the genetic algorithm and how it can be get involved with artificial intelligence. Thank you very